Hi there. Last week I bumped into a very exciting problem on 3 blues 1 brown channel with 64 bits of random information that you need to alter by altering 1 bit in such a way that the receiver knows which bit was marked by your action. The bit that has to be marked is predefined by some evil warden or whatever, and the receiver does not get the original string. He only gets the alter one. That's it essentially. And the solution that Grant has come up with is very complicated, and I think that mine is much simpler, so I decided to share. This problem calls for some kind of inductive approach, but going from step n to step n+1 doesn't work, since it dies on the second step with 3 bits of information. So my proposal is to go from n to n times n. Let's say we know a solution for n. We can then consider a matrix of n by n. If we need to mark one of the bits in this matrix, we essentially need to mark its column and its row. How do we do that? We'll assign a parity to every row. It will get a 0 if it has even number of ones, and a 1 if it has odd number of ones. This provides us a string of zeros and ones, which is exactly n bits long, and our assumption was that we know how to solve this. So if we need to mark this bit here, we know which bit to change. Let's say we need to change this one. So the parity of this row has to be changed. The same goes for columns, and it will lead us to the idea that in order to mark this column, we will need to alter, let's say, this column's parity. But in order to change a row's parity, you need to change any bit in it, because flipping this one to a 0 will or this one to 0, this one to 0, will flip the parity from 1 to 0. The same goes with column. So any bit in this column will do, and any bit in this column and in this row will do. So only this one works. We can change it, and we will communicate the required column and required row. And this solution works with any matrix n by m, as long as we know how to solve for n and solve for m. So we can go from 2 by 2 to 4 by 2 and then to 8 by 8 and solve the original problem. That's it.